So good evening, everyone, and welcome. It's 7 here in the UK, and our speaker is already there. And this is one of the in a series of talks that the Special Interest Group in History of Meteorology and Oceanography is organizing during the year, and this is our fourth talk this last year, and I'm going to introduce you to our speaker tonight, who is Jonathan Martin, who is the professor at the Department of Atmospheric and Oceanic Sciences at University of Wisconsin-Madison. I'm sorry if I'm slightly distracted by the people continuing to join the meeting, and so my apologies for that. And I want to say a couple of words about John, and these reflect his work in the history of, or rather in atmospheric physics and in dynamical meteorology. So Jonathan Martin, Professor Jonathan Martin, has taught at the Department of Atmospheric and Oceanic Sciences, University of Wisconsin since 1994. He has a Ph.D. in atmospheric science awarded at the University of Washington. He is recognized as one of the leading researchers in mid-latitude cyclones, where he's using a multi-scale approach which combines observational analysis and also the mesoscale modeling of selected storm. He has written a textbook on mid-latitude atmospheric dynamics. In 2016, Professor Martin has been awarded by the American Meteorological Society Edward N. Lorenz Teaching Excellence Award for, and I have to quote this because it's so well put, outstanding teaching and mentoring that combines boundless enthusiasm with consummate skill to educate and inspire a generation of undergraduates and graduate students. So belatedly congratulate John on this wonderful award from AMS. Tonight, however, John here is not here to speak about strictly his scientific work in mid-latitudes, but rather about the British meteorologist Reginald Sutcliffe, about whom John has published an acclaimed biography entitled Reginald Sutcliffe and the Invention of Modern Weather Systems Science. For the background of this study and his adventure in moving from sciences into history of science, you can read his account in the interview given to the Wisconsin Public Radio segment called The Weather Guys, which is now published in transcript on the internet. So I want to welcome John Martin tonight, but before we start with the presentation, just a couple of words about who we are, what we do, and why you made a good choice to join us here tonight. A couple of words about the history group of Royal Meteorological Society, which is formed in 1983, and is actually the longest running special interest groups of the society. We run a variety of meetings, some jointly with the society itself and others external to it. We have just recently had a well-attended and widely publicized meeting on the history of climate modeling in London. We also publish a newsletter, regular newsletter, with various items and articles in it. Occasionally, we publish the occasional papers and pen portraits of distinguished meteorologists and scientists, but also we continue to work and develop the Distinguished Voices podcast, where we have a series of conversation between leading meteorologists. Let me see. If you wish to join us, you're very welcome to do so if you're not a member. Membership is free. you will get the benefit of seeing the newsletter for a few, and you will get to find out about the events and meetings. Please follow the link here at the Society's website. However, you can simply Google Royal Meteorological Society History Group, and Google will find us for you. Any inquiry, here is the email, which has come to me, and we can add you to the list of recipients of our information. So if you're not a member, here are the benefits. Weather magazine on various technologies, discounts at conferences and paid for meetings on 6 other journals, including new online journal, Climate Resilience Sustainability, access to information and support for grants, and the discounts for any items in the Royal Meteorological Society shop. So please do so, again, by following the link here or by Googling us the way I described just a second ago. So with this, we would like you just a couple of housekeeping rules to say that if you have any questions as we go through the meeting, you can just simply send your question in the chat area, and we'll try to answer these in order of their appearances. Again, we'd like to ask that all the questions be relevant to the presentations broadly seen, and then that we may not be in a position to answer all of the questions given the time constraint. So without further ado, I want to introduce John Martin today with the title of his talk, Chasing the Giant, Reginald Sutcliffe, an Invention of Modern Weather System Science. John, please.
Thank you very much, Vladimir. Let me get my screen. It says I cannot start sharing screen while the other participant is sharing. I guess you have to get.
Yeah, I'll just stop sharing now. There we go.
So now. And there we are. Everybody can see that, I hope.
Yep.
So thank you again, Vladimir, and to the whole group. I'm very, very happy to have the opportunity to present to you tonight some of the results of what's really been a life-changing journey for me that I've taken over the last 6 years of biographical research into the life and work of Professor Reginald Sutcliffe. I think a case could be made that the cornerstones of modern synoptic-dynamic meteorology are really an application of the quasi-geostrophic assumption to simplify the equations of motion and facilitate physical insight, adoption of pressure as the vertical coordinate in investigations of the atmosphere, and then development of a diagnostic expression for the vertical air motion. And though a number of insightful and creative scientists have made contributions to the emergence of these elements, as well as our broader science in its modern form, I think a confident case can be made that Reginald Sutcliffe was the pioneer in all of these revolutionary developments. And so he's a very interesting figure, both scientifically and, it turns out, historically, I think, as well. Sutcliffe was born on Wednesday, November 16th, 1904 in Wrexham, North Wales. It happened to be a fair and nearly windless day in North Wales. I don't think they're too common at that time of the year. He was born in this modest house at 88 Bradley Road in the town of Wrexham. His parents, Jesse and Ormerod, were from Hebden Bridge in Yorkshire, and Ormerod was manager of the co-op in Wrexham. He had been involved in the cooperative movement since his late teens after having worked in factories as a young boy. In this picture in the mid-1920s, the Sutcliffes, as you can see, had 3 sons. Their oldest at the time was Robert, then Reggie, then Alfred, and they'd lost a son, William, in 1906. And so there they are living in Cleckheaton. Ormerod found doing business in Wales rather difficult, as he never really got a solid grip on the native language. And so the family moved back to the Yorkshire town of Cleckheaton in 1907 into a similar home pictured here at 9 Prospect Terrace in that town. And at the end of Prospect Terrace is a slow grade uphill to Whitcliffe Road. And about a half a mile up this grade is the Whitcliffe Mount Grammar School, which opened in 1910. And there's a picture of it in its former glory. It's since been destroyed, and a new building's been put on the footprint of the campus. But the school has a remarkable history. At the time, the several towns in the How did I get muted?
I'm sorry, that was a glitch. I'm sorry.
Oh, okay.
Yeah.
Okay.
Mhm.
They needed a new grammar school in the Spen Valley, and local government administrators had decided to expand existing facilities in the neighboring town of Heckman-Dwight. And that was not a favorable decision for the residents of Cleckheaton. That was going to force their kids to go 6 miles each way every day for their schooling. So a number of rich industrialists in Cleckheaton banded together to challenge the establishment, and they were quickly dubbed the Cleckheaton conspirators. And this group, what's going on? Can't move my screen. I'm not sure why. Oh, and this group proposed to build the new school on subscriptions. And in very little time, they raised the necessary funds to do that. And I thought when I was doing this research that this remarkably anomalous effort, it wasn't happening anywhere else apparently at the time, was motivated by a pervasive belief in the importance of a broadly available education. And this was articulated in a speech by one of the conspirators, Reginald Grills, in April of 1908. He said, "We live now under a democratic form of government where everybody has a vote. And it stands to reason that if the power to rule is given to many, but the faculty of reason belongs to few, the government is not a democracy at all, but government by the mob, something we're unfortunately familiar with in the United States. If we want to have a perfect system of democratic government, we must have an enlightened people. And if this were the only reason for a complete and universal system of education, that would be sufficient to justify everything we're doing in trying to improve our education." So this was a really interesting effort that was organized at a time when you wouldn't expect it. Sutcliffe began attending the school in 1916, sorry. And it was to have an enduring and substantial impact on him throughout his life. Here's a picture of two of the more influential people who he ran into at Whitcliffe Mount, the headmaster Herbert Claiborne and his science master William Pearson, who you'll hear about more than a couple more times throughout the presentation. Sutcliffe was a big man on campus. He was the head boy, he was the top male prefect in the school. He was a sports champion. Here he is as captain of the football team in his 6th form year. Here's some of his sports champion medals that I was able to get a look at his daughter's house in Norfolk. And in the 6th year, he won a county major scholarship, which entitled him to attend the University of Leeds. And he enrolled there in September of 1922. Now, the scholarship only paid for tuition and nothing more, so he was still living on Prospect Terrace while he went to Leeds. And given the 12-mile commute each way every day, he had a little time to experience college life. Though he did swim, he was on the swimming team, there he is on the far right, in his last year, and he was also president of the Mathematics Society, and that gave him a chance to give a public speech at an after-dinner event. And that was something he ended up doing quite a bit the rest of his life. That was his first such engagement. But the mathematics education he received at Leeds left him hungry for more. There was nothing particularly creative nor challenging about its pursuit as an undergraduate. He left somewhat uninspired, but he did do very well as a student. And so Leeds invited him to continue on for a higher degree, but they could not offer him support to do so. And so enter the Whitcliffe Mount School once again. Since Sutcliffe had won a county major scholarship to fund his undergraduate pursuits, the school's endowed scholarships had not been involved. And this led Claiborne and Pearson to suggest to Sutcliffe, hey, you should apply for the Alfred Law Scholarship from the school and make the argument that the funds will be used to pursue the first Ph.D. for any Whitcliffe Mount graduate. And it worked. So he began his Ph.D. work in September 1925 at Leeds under the guidance of Professor W.E.H. Berwick, who was a number theorist and an algebraist. Now, Sutcliffe wrestled with the vexing question that afflicts, I think, all neophyte researchers, and that is, what do I do and how do I start doing it? And he has this comment in his notes that he will always remember the introductory talk that Berwick had with him. He relaxed his tension by saying, listen, don't worry too much about your research at this stage. The important thing is to start doing something. And I've told my own graduate students that at multiple times in each of their trajectories. It never ends. It's never bad advice. You just, when you're in a rut, you got to start doing something. You usually find your way out of it. Well, less than a year into his PhD, Berwick was offered a professorship at North Wales, from which he had originated actually, and he accepted it. His family was there. And Sutcliffe scurried to figure out what to do. He was writing letters to the registrar on the campus, meeting with Berwick, etc. And he was determined that he should follow Berwick to Bangor. And when done with his degree, he would receive it from Leeds. So he set off in the fall of 1926. Here's Berwick's resignation letter. Consequently, it'll be necessary for me to resign my appointment at the University of Leeds, 30 September 1926. And Sutcliffe followed him, and he moved into this home at 37 Upper Garth Road, literally down the road from the Menai Strait that separates mainland Wales from the Isle of Anglesey. You can see the ocean there. Beautiful place, apparently. I've not been there yet. I'd like to go. But there's a pub at the end of the road that's right on the canal. But while he was there, he met a young lady from a Calvinist Methodist family in Pentry Halkin, 45 miles to the east, Miss Evelyn Williams, and there he is pictured with her. Evelyn was in her first year studying languages at Bangor, and by all accounts, Sutcliffe was instantly smitten with her, and she was, of course, indifferent. In fact, her daughters tell me she was at the time interested in some local rugby tough guy. But Sutcliffe was persistent, and though the details of that persistence are lost to the ages, we do know that he eventually won her undying affections, and she was an active, inquisitive, progressive young woman, qualities she never abandoned and which never atrophied. And they were well matched and had a fantastically happy life together. By the end of his only year in residence at Bangor, however, Sutcliffe completed his Ph.D. under Berwick. And I feel like I must be one of the only people in our science, actually, who have ever seen this Ph.D. thesis. Maybe the number doesn't go much larger than that. His daughter, Jenny, had a draft of it. So the title is exceptionally long. I can't read it because part of the screen is obscured, but it goes on and on and on. And of course, reviewer comments are going to come at the time when you submit a thesis. And despite the fact that voluminous comments were given back to Sutcliffe, none of them suggested shortening the title, which is really an onerous title. But the reviewer comments are interesting because they foreshadow what I think happens in Sutcliffe's career. And I highlight just a couple of them. The author goes on in this one, however, with a practical aim in view to modify and supplement these formulas of complex variables and so on. And these formulas will be undoubtedly of practical value. So there's always a practical aim in view in this reviewing of Sutcliffe's work, even as a PhD student in mathematics. Berwick himself thought that this makes a useful addition to the theory initiated by Klein, on which I hope Sutcliffe will work again. And of course, that was a vain hope. Sutcliffe never again did applied mathematics. In fact, he was one of only a very few students who studied with Berwick, whose health began to fail with the move back to Bangor. As it turns out, in the late 1930s, he began to wage what was termed a long battle with illness, undescribed, and I couldn't find any particular reference to what it was, but he ended up not being able to come to the office, and 3 years after that point died. And so it does sound like ALS, although I don't know if that was the case. So Sutcliffe graduated in June of 1927 with his PhD, and as difficult as it may be to believe in the current day, 100 years ago, a PhD in mathematics was not, as it is today, a highway to many potentially lucrative job prospects. And so the pickings were rather slim for this newly minted PhD from Leeds. But luckily, there was a primitive placement office there, and Sutcliffe was friendly with the contact, who informed him that the meteorological office often looked for mathematics graduates, so he should give them a ring, which he did. And he eventually arranged for an interview at the Met Office's Kingsway headquarters, which is now a science museum. And the interview took place on the 5th of September, 1927. It was conducted by David Brunt, later to be Sir David Brunt, and apparently lasted no more than 5 minutes. One gets the impression that Brunt was told while everyone else was on vacation, if this person doesn't look like a complete disaster in person, hire him. And so Sutcliffe was offered a job, and he began what would be a distinguished Met Office career on Friday, the 30th of September, 1927. Now, he'd never been to London before in his life, and he was only 2 years removed from living at home. So it was a time of great personal adventure, though some uneasiness since he was far away from Evelyn in Bangor. But family legend has it that during the next summer of 28, Reggie took an extended bicycle ride up to Bangor, 250 miles, with a friend of his from London to visit Evelyn. And we don't know whether or not that was the first time he met her parents, but when he did, her father, who was a Calvinist Methodist preacher, insisted that he learn the Welsh language if he were serious about Evelyn. And he had some success, certainly more than his father did, and in any event, apparently enough to satisfy his future father-in-law. So Sutcliffe was charged with compiling statistics regarding air routes over the Mediterranean when he was hired at the Met Office. And within about a year of the beginning of his employment, he was sent to the tiny outstation at Malta in the center of the Mediterranean Sea. And of course, by this time, Mussolini had been in control of Italy for a number of years, and he had it as his stated goal, reconquest of the Mediterranean. He also had the largest submarine fleet in the world. And this was, of course, objectionable to the British, who had a number of interests in the region, Egypt, Malta, and Gibraltar among them. So they were particularly interested in ensuring that they could quickly come to the aid of any and all dominions, and understanding Mediterranean weather and its effect on shipping and air travel was a very high priority. So that's why Sutcliffe ended up heading to Malta. And as luck would have it, he arrived just weeks after Tor Bergeron had started a 6-month visit to Malta at the invitation of the Met Office to explore the efficacy of the Norwegian analysis methods for forecasting in the Mediterranean. Now, of course, Bergeron took the opportunity to instruct the 5 staff members on the Norwegian methods, and this really reinvigorated Sutcliffe's enthusiasm for meteorology as a science. In his own testimony, his first year of service in the Met Office was hardly inspiring. This was a mathematician, fairly gifted young one at that, and he had begun to sour on the entire science as lacking any rigor and or any physical or mathematical theory to underpin it. So this interaction with Bergeron was really an enormous shot of much needed intellectual adrenaline for Sutcliffe. The following spring, Evelyn, who was only 20 at the time, comes all the way down to Sliema, Malta. We don't know how, by ship, train, taxi. Maybe she came with an Air Force wife or something like that. We don't know. To marry Reggie Sutcliffe on Tuesday, March 29th, 1929. And they set off, spending the next 3 years in the subtropical beneficence of Malta, some of the happiest of their long lives together. And Sutcliffe was attracted to research, even though there was a prohibition against its pursuit during the regular workday in the Met Office. Despite this official prohibition, it was also at the same time well understood that interesting research work was a means to attract the attention of higher-ups that might lead to promotion. So Sutcliffe made a number of interesting, though quite low-profile contributions during his first years at the Met Office. He did an experiment in June of 1928 where he made the sling psychrometer wick and muslin was changed every day on one instrument and not on another one. And what was the influence on the wet bulb temperature? There was some notable and statistically significant influence. How did Atlantic ship observations affect Mediterranean forecasting? There are gravity waves in the fall at Malta that he explored, and also made a comment on places like Malta, where if you get most of your rain in several high-profile events in a given year, how do we have any chance of making long-term forecasts? So interesting, but low-profile examples of research. But he was getting his game going, and he was returned to England in October of 1932, and moved to Felixstowe for duty in December of 32. And he considered several problems of local interest at Felixstowe, including the sea breeze. And in fact, a paper that he wrote by himself, a single-authored paper describing results of his sea breeze research, was published in the Quarterly Journal in 1935. I believe that's his first quarterly journal publication. And it was read before a skeptical G.I. Taylor, as it turns out, in November of that year, but by one of Sutcliffe's colleagues, because Sutcliffe had been deployed to the Mediterranean in October of 1934, as a show of strength against Mussolini, who was, of course, threatening Abyssinia. So he was deployed to Alexandria in this whole period of time, October to April 1936. And on a cruise to Palestine at Christmas time, 1935, Sutcliffe found himself in Nazareth on Christmas Day. He was not a religious person, but he took the opportunity to buy a rosewood Bible for his soon-to-arrive first child. He must have been informed during this time that his wife was pregnant back home. And so he inscribes in the book to Ellen from her daddy for February 19th, 1936. So this was bought months before her birth date, which might account for the somewhat awkward inscription. But Ellen didn't know where this Bible came from, nor why would her father have inscribed it the way he did until I began this research. So this was a real thrill, to explain this family heirloom by putting my nose into their family's life, and they allowed me to do it. It was really nice. So quite an interesting event for me. Well, in Felix, Sutcliffe was posted to the Air Ministry headquarters at Kingsway, effective in April of 1936. And at the time, Royal Air Force and private pilots were required to take elementary courses in meteorology for certification. And the Met Office was responsible for overseeing this examination process. So Sutcliffe was put in charge of that whole task upon returning from the Mediterranean that spring. He did like the job, but he thought the examination process, though, suffered from the fact that there was no standard text for the syllabus for the courses that he taught. And after a year of this, his frustration grew to the point where he had to propose a formalized syllabus and the commissioning of a textbook to the director of the Met Office. To his astonishment, Director Simpson agreed that both of those things needed to happen. And what's more, he thought Sutcliffe should write the book, and he wanted it done in 6 months. And Simpson also realized that the coming to the office every day wouldn't provide an environment conducive to that important work. So he suggested that Sutcliffe work on the book at home on the south coast of England in the spring and summer. This was so sensible that, of course, it was nearly derailed by bureaucrats. But the idea did, in fact, prevail. And in the spring of 1937, the writing and the 6 months of at-home leave began. And important for us as scientists in this field is that this project gave Sutcliffe time to do his first extensive reading in meteorology. It's a subject with which he was not academically familiar as a student, and even after a decade in the Met Office, given his various jobs, he was not particularly well-versed in the meteorological literature. So this was a really big moment. And in the spring of 1938, the book was published. It's called Meteorology for Aviators, and it became a huge hit. This book is all over the place. Apparently, everybody in the Royal Air Force had a copy of this. Probably ended up on Luftwaffe pilots' desks as well. And Sutcliffe's name became synonymous with meteorology through this book. So it's really quite a well put together book. And after it was finished, he was posted to the climatology section of the office because they figured, well, this guy's done such a fine job on this. Let's have him write pamphlets describing the weather around the world for all of the different Admiralty pilots. Sutcliffe was horrified at this prospect. He thought he'd be bored to tears. And so he exercised his privilege of seniority to apply for another post. And he was assigned as an instructor at the Royal Air Force School of Naval Reconnaissance at Thorney Island on the South Coast. And that was effective March 30th, 1938. This was a dream come true for Sutcliffe and Evelyn. And he began to think about unsolved problems in meteorology because his job was not terribly taxing. And as a long-serving forecaster, chief among these outstanding problems was the development of cyclones and anticyclones. Where do they come from? How do they develop? Why don't we know more about it? And several landmark papers followed this time of self-education. The first of those was a joint effort with Durst and Sutcliffe, 1938, the importance of vertical motions in the development of tropical revolving storms, a fairly incredible title for what, of course, we now know as tropical cyclones. The problem discussed is that of the mechanism by which the eviction of air from tropical revolving storms occurs, and it's done by examining the equations of motion. This was a revolutionary approach at the time. Here's a bunch of words that probably soured people on synoptic dynamic meteorology in the 30s. When you read it, it doesn't make any sense and it's difficult to follow. If vertical motion occurs in the atmosphere in a region of horizontal temperature gradient, then ascending motion gives a component of wind from warm to cold and descending motion a component from cold to warm. Unfortunately, this kind of language was what barred synoptic dynamic meteorologists from being considered serious scientists, I'm afraid, at that time. So Durst and Sutcliffe endeavored to figure out a way out of that problem. They started with the notion that taking the vertical cross product of the acceleration vector is the way to isolate the ageostrophic wind in a frictionless atmosphere. And so one can expand the Lagrangian derivative into a Eulerian, a horizontal advective, and a vertical advective derivative. And what they focused on in this paper was applying this vertical cross product operator to the vertical advection term. And before they did so, assuming that the flow is geostrophic, which is way out of bounds for a tropical cyclone, of course, but let's just see where the mathematics leads us is, I think, the way they approach this. So the thermal wind equation in height coordinates is ugly. It involves a reciprocal of temperature and a gradient of temperature, but you can rewrite W dV dz this way by assuming thermal wind balance. And then you have to take the vertical cross product of this expression. And so it's going to become minus W over FT times the gradient of temperature. And if you're looking for, here's a situation in which you've got warm air to the right, cold air to the left. So the core of the hurricane is on the right. And this yellow shaded region indicates a region of ascending air. So W is positive. Then you can figure out what will be the X direction ageostrophic wind. it'll be minus W over F squared T dt dx. W is positive in the yellow shading, dt dx is positive, so the whole term is negative. You get an ageostrophic wind that appears to be evecting mass out of the core of the tropical revolving cyclone. And that's done by looking at the equations of motion. So this was a revolutionary, though completely erroneous approach that was taken by Durst and Sutcliffe in their 1938 paper. Sutcliffe goes off on his own the next year and talks about development in the field of barometric pressure. And he says that the rate of change of surface pressure is defined by the horizontal divergence of momentum integrated vertically through the entire atmosphere. And pressure changes, therefore, are defined solely by the field of acceleration. And so they can be put to dynamical scrutiny. And what he does here is he takes the exact same expressions from the Durst and Sutcliffe work that I just reviewed. In their full ugly glory, they look like this in the green box. And he stuck on this vertical advection term, but then says, now you can make some approximations here with a practical aim in view, perhaps, just like he did in his PhD. And you can say, what if we assume that the flow is quasi-geostrophic? This is the first English language invocation of that phrase. And it's in this paper by Sutcliffe in 1939. And upon doing so, you get the same simplification that they unveiled in this Durst and Sutcliffe 1938. And finally, 1939 dawns. It's going to be a bittersweet year for Sutcliffe. Meteorology for aviators makes his name synonymous with the word meteorology, probably across all of Europe. And he also writes what is really one of the most fundamental papers in our science in 1939, the cyclonic and anticyclonic development paper. This is the forerunner to the development equation, the first omega equation. A criterion for development is that there should be a significant difference between lower and upper fields of divergence. And that is the starting point for this analysis. So once again, starting with the fact that the vertical cross product of the acceleration vector renders the ageostrophic wind, Sutcliffe says, why don't we apply this at two different levels? A level at the surface, V naught, and the level at the top of a column, which is V, and in between, there'll be a shear vector that connects the surface wind to the upper level wind. And if you apply that same expression, just the acceleration part, dv dt minus dv naught dt, one can show, and he does in this paper, that you can, that's going to be forced any difference in the acceleration at the top of the column and the acceleration at the surface is going to be dependent upon these two terms, which are relatively ugly, especially the first one. If you expand that first term, it has four full expression, the full expression of it has four terms, but it's not hard to get to that. If you then draw a clever picture, which he does in the paper, which is make sure you just draw a picture that will simplify this expression in a number of ways. The first way is draw your isotropes meridionally so that there's no y direction temperature contrast. That means there isn't going to be any shear. We're going to assume the flow is geostrophic. There's no vertical shear in the x direction. So those two terms will go away. And then if you consider the geostrophic winds around a center of low pressure at the surface, there really isn't going to be any such thing as a dv naught dy term. So that will also disappear. And so this whole thing, ugly though it might be, results or reduces to this one term applicable to a picture like this. V sub s is just the y direction thermal wind, and that'll be moving in the up the positive y direction. Du naught dy surrounding the low is of course negative. So this whole term will indicate a negative I directed Vs dot LV naught vector, and then you have to take the vertical cross product of that, which renders a net column ageostrophy headed up shear in the flow and net column ageostrophic divergence down shear of the cyclone center. And so this is the first time there's an explanation dynamically for why cyclones move in the direction of the vertical shear. It also provides an explanation for why anticyclones move in the direction of the vertical shear. And when you put those two together, you find out that the poleward migration of cyclones and the equatorward migration of anticyclones sustains the mid-latitude jet. And we now talk about that as the eddy-driven jet. All of this is derivable from this great insight by Sutcliffe in 1939. The second term is just the rate of change of the shear vector itself. And if one assumes that the flow is geostrophically and hydrostatically balanced, it's the rate of change of the thermal wind. So if you think about what's happening at that purple dot, you've got geostrophic confluence, the primary flow pushing the isotropes closer together. That's going to compel an increase in the vertical shear in the direction that's indicated in orange. Vertical cross product of that renders net column ageostrophic divergence on the warm side of such a confluence zone and net column geostrophic convergence on the cold side. And this produces the transverse frontal circulation that was made more famous by Sawyer in Eliason of some 20 years later. It was in Sutcliffe's paper, but I don't think he quite saw that. So this was a huge advance. Sutcliffe was primed to become the synoptic dynamic meteorologist in the world at the time. But of course, that wasn't to be. September 1st, Germany invades Poland, World War II begins. And within weeks, Sutcliffe is called up to service in the Royal Air Force Volunteer Reserves. And this is his conscription document that I had the great pleasure of seeing in his daughter's archives. And you can see all there, Reginald Cockcroft Sutcliffe called up on the 10th of October, 1939, and for the duration of hostilities. And nobody knew, of course, how long that was going to go. So Sutcliffe's first role was at the Bomber Command HQ in London. Then in November of 1939, he went to the headquarters on the continent in Arras, France, and there were 6 months of the phony war. He bemoaned it as professionally terrible, trying to be an operational meteorologist with no facilities and very uncomfortable personally, of course. And the German invasion of the Low Countries and Denmark and Norway began in early April, and then Belgium and France were next on the list in early May. The Germans, of course, made rapid progress, and in Belgium and France, and on May 17th, the headquarters at Arras had to be moved 70 miles west to Boulogne, where the Allies figured they'll be safe. That wasn't true. Less than a week later, of course, Boulogne was captured. 4,500 British servicemen were shipped back to safety on May 23rd to Dover. Sutcliffe was among them. As soon as he got back, he was told, "We want you to lead an expedition in the south of France for the purposes of forecasting for bombing raids in industrial northern Italy." This was known as Haddock Force, Operation Haddock Force. So Sutcliffe flew from London back to Orleans on the 5th of June, 1940. He was then in charge of driving a convoy of trucks down to Ceylon. On the 7th of June, he got there and they set up operations, and it was a complete nightmare in terms of they didn't actually have any bombing operations at all, maybe one run on Milan, and the French and British were fighting there in terms of what they were going to be doing with this operation. And eventually they decided to evacuate. So they evacuate from Marseille to Gibraltar on June 18th, 1940, and then zigzag from Gibraltar back to Liverpool and get there on June 1st, 1940. Now, keep in mind that by about mid-June, after the capitulation, actually maybe by the 20th of June, the BBC was broadcasting back home that any British servicemen still in France were either captured or deceased. So you can imagine that Ellen and Evelyn up in Oxford, staying with Evelyn's sister, were wondering what is going on after about the 20th of June. And that's a really difficult 2-week period. So imagine the joy when on the 1st of July, 1940, this telegram laden with just 9 words arrives. Just arrived, feeling grand, see you soon, love, Reggie. So Ellen told me, when she has this at her house, she told me that when this arrived, she remembers her aunt and her mother in the vestibule hugging and crying. And she said, "I don't know how to explain it, but I felt this weight just lift over me." And I was only 4.5 at the time. And she remembered that 75 years later. That's remarkable. So I'm so glad we have this artifact, and I was actually able to see it. Sutcliffe was given a week off until about July 10th. And then he was posted as Chief Meteorological Officer at Bomber Command at High Wycombe, but there was nothing really to do there at the time. And so on the 7th of October, 1940, he was posted as Senior Meteorological Officer at No. 3 Bombing Group at Exning, Newmarket. And he'd be there continuously for the next 3.5 years. So the Sutcliffe family, and it grew a little bit during this time. His second daughter, Jenny, was born in May of 1943. They were able to stay together during the war, which was unusual for people in the service situation that of the type that Sutcliffe was involved in. But he was busy. He was really busy. He had lifelong nightmares after the war for all the things he was doing, sending, sorties to bomb German cities and whatnot, and losing pilots and losing people on the ground. Miserable effort, of course. But he was doing some really important work. He was mentioned in dispatches 3 times. The first time was in September of 1941. He was eventually made an Order of the British Empire, OBE, in January 1942. And most of these initial awards for his work were a result of what he was doing for forecasting flight level winds. And this was based upon, and there's Ellen and Evelyn outside Buckingham Palace in July of 1942 when the OBE was bestowed upon Sutcliffe. Most of that work, the recognition, was from work based on flight level winds and their forecasting. And this was a function of a couple of different ideas that were ruminating in Sutcliffe's mind in the early 30s and early 40s, and he eventually wrote them in a technical memorandum in 1943. Construction of upper isobaric contour charts was number one. And the second paper in this group he did in collaboration with the Belgian polymath Otto Godot, who he worked with at number 3 bomber group for a while. And this was forecasting upper level contour charts themselves. And the relative height of a given upper isobaric surface is a function of temperature only. And so its local change with time is determined by isobaric changes of temperature within the air column. This was an insight they really put to the test. And so here's the idea. If you have sea level pressure analyses in blue, they're plentiful. They were not hard to come by across the continent even. The resistance could provide observations when necessary. And occasionally even the resistance was able to provide a vertical temperature sounding. And that, coupled with flight level winds and some air mass analysis techniques that are no longer really used, could give one an idea. There's some of the few radiosondes that one might have to help construct the red dashed set of contours, which might be the 1,500 millibar thickness lines. And so in pressure coordinates, graphical addition of the 1,000 millibar height field and the 1,500 millibar thickness could give you a 500 millibar height field, which is approximately flight level. And since the thickness contours in a given column were rearranged by horizontal advection by the 1,000 millibar wind, just as well as by the 500 millibar wind, which you didn't have direct access to, one could extrapolate the evolution of the thermal field in a way that was dependent on getting a new sea level pressure analysis. And in such a way, you could get a new 500 millibar height guess from graphical addition. And so great advances were made by adopting isobaric coordinates in flight level wind forecasting, and Sutcliffe was recognized for those advances. And all the while, of course, he's thinking about his 1939 paper about how do we develop cyclones and anticyclones, and thickness. So that's an interesting variable. And suddenly turned on to thickness, and that becomes part of the way he's thinking about this whole complexion of weather systems problems. In late March of 1944, after months, literally months of behind the scenes maneuvering by Director Johnson, Sutcliffe was posted as the Chief Meteorological Officer of the Allied Expeditionary Force at Fighter Command at Bentley Priory. But he didn't like this job either. He was posted as a civilian. By this time, if you were on home territory, but not in the military, you had to go in civilian dress. And this was a fighter command. Everybody was in uniform. So he felt like a fish out of water. And they didn't have very much input, fighter command, at the decisions regarding the invasion of the continent, Overlord. Although Stagg's book on Operation Overlord makes a clear point that Sutcliffe had a couple of really key insights late in that first week of June 1944. But overall, he was not happy with being at Bentley Priory. And after the invasion, he followed, of course, the Allies. He went from Bentley Priory to Granville in late June of 1944, then followed again when Paris was liberated to Versailles in August of 1944. He lived in a horse stable off the palace grounds and had really no responsibilities of any particular type there either. He was kind of biding time. But then finally, in the fall of 1944, he was sent to lead Chief Meteorological Officer at the 2nd Tactical Air Force and the British Air Forces of Occupation, which it later became known as. And that was in Brussels. So he was at a really fine institute with good facilities, and he was reunited actually with Godot. So they had some serious work to do in the fall and early spring of 1945. In fact, Sutcliffe was the chief forecaster for the crossing of the Rhine, which occurred in March 1945, and that was Operation Varsity. So this is a staged picture, as it turns out, of Sutcliffe on the left, Conyngham next to him, and then Louis Brereton, and then Air Marshal Groch. So they're pretending to consider the invasion and the weather associated with it, and it had already happened. But Sutcliffe made the forecast. He was the chief forecasting person there, and it was a day of strong anticyclonic conditions, so not a tough forecast as it turns out, he says anyway. And then finally, Sutcliffe ends up in Bad Ilsen in Germany and spends a year and a half after the war ends, or almost a year, I should say, rebuilding the German Meteorological Service as the chief meteorological officer of the 2nd Tactical Air Force. And this important work delayed his demobilization for an entire year. He wasn't demobilized until late April 1946. So it was a nothing but administrative headache, but he was really good at that, and it was recognized as such, as it turns out. But upon return to England, the Met Office was in need of reorganization. Its ranks had swelled by nearly 60% during the war. So for a period of months, Sutcliffe had no substantial responsibilities professionally when he came back. And so he took to organizing his thoughts about the development theorem and what all these other things that he tinkered with during the war. And he chiefly went back to the development theorem. And what a tremendous insight this was. Remember, before the war, he had this notion that if you take the divergence of the vertical cross product of the acceleration vector, that's the same in a frictionless atmosphere as taking the divergence of the ageostrophic wind, which now, steeped in isobaric coordinates, he knew was related to the vertical derivative of omega. All the work that went on in the war, he had no time to sit and think about rearranging these 3 vector quantities, because when you do, it turns out that the divergence of the curl of the acceleration is the same as the curl of the cross product of the acceleration. And you're not going to change the product, but what's in yellow becomes the vorticity equation. And so suddenly Sutcliffe has a link between divergence and vorticity that he'd not thought of before. And so the local change of the vorticity plus the advection horizontally, assuming the flow is geostrophic, except in the divergence, is going to be equal to minus F times del dot V. Then Sutcliffe goes back to the same old idea, apply this expression at 2 different levels in the atmosphere. And when you do, forgive the rearrangement, I've made the left-hand side, the right-hand side, and vice versa, you get a difference in divergence at the top minus the bottom of the column is going to be the result of a difference in horizontal advection of vorticity at the top minus the advection at the bottom, minus, since the vorticity, geostrophic vorticity is del squared phi, this is going to be the Laplacian of a temperature tendency, effectively. This is the rudiments of the development theorem. Sutcliffe goes through all manner of interesting mathematical exigency to get to the final answer, but the final answer is what we'll talk about today. And that is that left-hand side, divergence at the top minus divergence at the bottom, is forced by the thermal wind advection of the column vorticity. Remarkable, simple insight, fit for the times, because it was not relying on a set of observations or diagnostics from those observations that were not routinely available in the 1940s. You could get a thickness field, you could get a geostrophic vorticity field, and so on. And so this was immediately applicable. And here's an example that I took, it's in my textbook as just an example of this theory. Here's the sum of the geostrophic vorticity at 9 and 500 millibars plus F. That's shaded in orange. And then the 500 and 900 millibar thickness is the dashed red line. Here's the thermal wind advection in red and blue. It's blue is negative, red is positive, of that same quantity in the same layer at the same time. And then you can see in the light gray shading is just a ghost of that. Then, if you think about inverting this forcing, this is the 500 millibar quasi-geostrophic omega that results from that collection of forcing. And this is the actual numerical model, primitive equation vertical motion, same scale and remarkable similarity. And this was a revolution. It can't be overemphasized how revolutionary this was to operations. We didn't have computers quite yet in 1947 to make this thing work quite the way it does today, but the insights were there. And it was a huge leap forward for understanding weather systems. And as a consequence, this work reintroduced Sutcliffe to the meteorological research world, and at a similarly high plateau as he was in 1939. He won several awards for it, including the Groves Memorial Prize in 1951. It motivated the initial work on British numerical weather prediction. Here's Sutcliffe and Rossby in Stockholm in 1952. Of course, Rossby, Chani, and Edey, or especially, I should say, Rossby and Chani took a barotropic approach, which compressed the entire atmosphere into one level. Sutcliffe was skeptical that that could prove valuable at all. Of course, Rossby showed that it could, but Sutcliffe was interested in exploiting the development theorem and using it right away as a more complicated baroclinic way of looking at development and injecting it into numerical weather prediction at its incipience. And unfortunately, because it was more complicated, it had a little bit longer spin-up time. And so the barotropic processes suggested by Rossby and Charney won the day in the 1950s, but they didn't win the day in the long run, of course. He was elected to the Royal Society in 1957. And this was the first time that a synoptic-dynamic meteorologist was brought into the holy precincts of the Royal Society. And so this event put synoptic meteorology and weather forecasting into the constellation of respectable, rigorous physical sciences. And as institutes tend to do around the country, when the list of new Royal Society members is announced in the spring, Leeds, the chancellor at Leeds, was combing over them and said, oh, one of our graduates was just elected to the Royal Society. And look at who the president of the society was at the time, David Brunt. Isn't that interesting? Sutcliffe wrote a letter back to the chancellor, who had written him a letter saying congratulations. And I just want to read the letter because it's so well composed. And here it is from the Leeds archives. Dear Sir Charles, I am so glad that my election to the Royal Society has been noticed with pleasure at my university, and that you should have been moved to write me personally about it. Some of us cut away from our universities, as we do from our parents, with gratitude unspoken, and never find the right occasion to express the warmth of our regard. Of course, we owe everything to them, and I would like, through you, to express a deep gratitude to Leeds after 30 years of enjoying the fruits of the trees there planted. Very many thanks. Yours sincerely, R.C. Sutcliffe. Beautiful letter, and at a really high profile moment in his life. He was made a companion of the Most Honorable Order of the Bath in 1961 by the Queen. And there's the award itself, which his daughter Ellen still has. And here's a picture of Ellen, her husband Dick, Reggie, and Evelyn outside Buckingham Palace again for another award. He'd been there 3 times by this time now. The next summer, the royal couple itself visited the newly opened Met Office headquarters in Bracknell, and there's Sutcliffe with Prince Philip, giving him a tour of the 500 millibar map or the surface chart or whatever it might be there. He's meeting the Queen in the lobby. He just met her the year before, of course. He was awarded the WMO Prize in 1963 in recognition for his outstanding contributions to dynamic meteorology, his furtherance of international cooperation in the science of the atmosphere, and his leadership in research. And after this, he took a huge role in WMO in terms of international outreach efforts. And that's described in the book. And that's a really big part of his life, actually, as it turns out. In March of 1965, he traveled back to his grammar school, the Whitcliffe Mount School, for the last time to deliver his second Pearson lecture. And here's the headmaster, the science master Pearson, there in, proud of his students. And they gave an annual lecture on science. And look at the title of this one, Predicting and Controlling the Weather. At the emergence of numerical weather prediction, it was actually first thought it will be a means for us to understand where we ought to explode nuclear bombs to rearrange the weather. In order to do that safely, we better be able to predict it. That's actually true. And of course, many of you probably know that. It was remarkable to find that out. He resigned from the meteorological office in the summer of 1965 for 2 reasons. One, he wanted to avoid working under B.J. Mason. Apparently, they got along fine. But Sutcliffe didn't really like what he considered to be sort of what I guess we'd call today a grandstanding attitude. But Mason, of course, was a really important figure in the Met Office history, and they were not at odds. It just he didn't want to work for him. And he also had the opportunity to establish the Department of Meteorology at the University of Reading. And so he jumped at the chance. And so at the same time, Sutcliffe was finishing up a popular book on weather and climate that he'd been commissioned to write in 1962. Oh, there's a picture of him at Reading. And the publishers misspelled his name on the cover. Look at that. That's terrible. And they told him, of course, no, we didn't release any of this, but his daughter had one of these copies. But anyway, upon sending him a letter of apology, they asked, would you please write us a textbook in meteorology for undergraduate scientists? And he declined. He was too busy at the time, which was unfortunately a great loss for our field, because I'm sure it would have been an outstanding book. This book, Weather and Climate, is one that's well worth a read, as it turns out. So as I mentioned earlier, in the process of conducting the research for this biography, I was fortunate enough to make contact with the Sutcliffe family and to enjoy their company on a number of occasions. This is Christmas 2014, or right around Christmas. And Ellen is at the table on the left, her husband Dick, their daughter Lucy to Dick's right, to his left, I guess. And then Nick in front of the Christmas tree is Lucy's husband, their sons Sam and Rory. And then Ellen and Dick's daughter Harriet and her husband Dave. And I must tell you, one of the greatest things about doing this work was getting to know these people and being greeted as a Yank, coming over and trying to find out everything I could about their famous father's life. And they were really grateful for that. And they've taken me, and it's been really wonderful friendships that have developed because of that. I also had an opportunity to meet his younger daughter, Jenny, and her husband, Jacques, in Brittany. They live in Brittany. And I traveled also to Pentry Halkin in Wales to the Sutcliffe gravesite, which has the first line of Shakespeare's Sonnet 33, full many a glorious morning have I seen, because it's filled with weather imagery on that. And so considerably more detail on many of these stories and a host of others are contained in my recently released biography, which you can see the cover here. And it's available from a number of different sellers. So I want to thank you all again for your attention and for inviting me to give this presentation, and for your interest in Reggie Sutcliffe. I really think that it's easy to glance at a cell phone, get a 5-day forecast, and take for granted where it all comes from. And it came from a lot of hard sweat and hard work and great advances. So thank you very much.
John, thank you very much. This was just a wonderful, wonderful tour de force. I personally, I don't know what about the others, but just a combination of your personal stories and access to the materials that you got from the family, and then the mathematics and physics and contextualization of the history of this early research is just amazing. I mean, it's been really a great pleasure. I really much enjoyed this. So I'm inviting the audience to send questions to John or to speak to the whole group directly. So please go ahead. But we do have a question already from Martin Young, and a really interesting and provoking question, which is that do you think Sutcliffe would have entered and contributed to meteorology if he had been born 50 years later?
Oh, that's a great question. Thank you, Martin, for that question. I don't feel I'm qualified to answer it. I'll give you my guess. And I'll preface it by saying that one of the things that was difficult about pursuing research on Reginald Sutcliffe was that he left almost nothing behind, no diaries, no anything. So one has to imagine what he was thinking at various times in his life. Sometimes that's not so hard to do because you can see what the responding action was, that from a prompt. And so one can imagine what he might have been thinking. That is a great question. I think he was genuinely interested in mathematics when he was in graduate school. I think he really did enjoy working with Berwick, and he wanted desperately. And in fact, the reason I can say this is because he was the letters I didn't share with you about his asking around through the University of Leeds, registrars and various other people, what should I do now that my advisor is moving back to North Wales? What should I do? He was clearly very interested in working with Berwick. And so 50 years later, had computer technology already been flourishing, had it been already established that one could make a prediction of the weather, it might not have attracted his attention. It's quite possible that would not have been the thing that he was most interested in. Although the book contains lots of different excerpts from essays that Sutcliffe wrote and at various public events at which he spoke, where he decried the fact that physical scientists were being trained to be atomic physicists and people who knew how to fix radios. And he actually used those terms. And yet they weren't really getting a solid grounding on how the universe works. And so maybe there would have been a temptation on his part to continue to work in a field with so much mystery as the one that we all have spent our lives thinking about. So I don't know. It's a great question. I really wonder what the answer would be.
Thanks for that, John. The next question we have from Robert Naylor. Thanks for an amazing talk. I'm really interested in what got you hooked on Sutcliffe's story. Was it a single moment, or did your interest develop over time?
Yeah, thank you, Robert. Great question. That one I have an easy answer for. When I was first offered the job at Wisconsin in the spring of 1994, I knew that my first job was going to be teaching a class in synoptic-dynamic meteorology to senior undergrads and first-year graduate students. So I had no notes. I had to put my notes together on how I would do this. And so I would spend, many nights in the library going over with a handful of books, reading through and kind of cobbling out some sort of a schedule and a syllabus. And it occurred to me after about 3 or 4 weeks of this that Reginald Sutcliffe's name kept coming up everywhere. It was impossible to talk about the omega equation without referencing Sutcliffe. It was impossible to talk about isobaric coordinates without referencing Sutcliffe. And when it came to fronts and frontogenesis and the vertical circulations around fronts, I had a thought, well, maybe Sawyer and Eliasson will be the place where I base everything on that. But even there, the 1939 paper intrudes again to show that if the rate of change of the shear vector drives transverse circulations at fronts. And so I couldn't escape Sutcliffe. And right from then, 1994, 20 years before I finally had the opportunity to act upon this desire, I thought, this is a person whose reputation is way below the horizon where his accomplishments and contributions suggest it ought to be. And I bet this will be an interesting story. And so that was the reason I went out and did it. If I hadn't met his family, I couldn't have made it personal as well. And I think it would have suffered from that. But the original impetus was just, as I put my notes together, I realized Sutcliffe's fingerprints are on everything in modern synoptic dynamic meteorology, and he needs to be described in more detail.
Thank you for that. Next question from Robert Moore, a biographical question. Do you know why Sutcliffe was buried at Pentre-Halkin, which is 5 minutes from where I live?
Oh, that's really interesting. I do know that, Robert, and it's described in the book in the last chapter. That is Evelyn's hometown, and he had, of course, great respect for her and her family, and so that was something they decided together, that they were going to be buried together, and she wanted to be buried in the churchyard of St. Mary the Virgin in Pentre-Halkin. And I visited the church, which was really quite a nice experience. So that's the reason. I can tell you this, though, too, that Evelyn did not travel to Pentre-Halkin on the day of his burial in June of 1991, because she wasn't really that she was so distraught. That wasn't the reason. Of course she was, but that wasn't the reason. She just couldn't afford the travel, didn't want to make the trip, but her family went. And he insisted before he died that there'd be no, quote, religious mumbo jumbo when he was laid to rest. And she did not have the same prohibition against her own interment, which was in July of 1998. She died on her birthday, actually, on July 30th, 1998. And so they're buried together, her ashes in his body. But that's the reason why, because that's her hometown. And they had a long-standing agreement about that.
Thank you for that. We have from Julian Mays. He made a transition. Sutcliffe made a transition to academic life at quite a late stage in his career. Do you think he took to teaching at Reading willingly with few other staff at first?
Yeah, that's a very good question, Julian. I noticed the same. I'm at about the age that he was when he took that job, and I'm feeling just the opposite. It's been a long career, and it's kind of nice to imagine not teaching anymore. But I think, his career is two things that I think about. His career is sprinkled with teaching opportunities a couple of times. He was the instructor and also the test giver for Admiralty pilots and private pilots in the 30s when he was at Felixstowe. He never shied away from doing that again. He had a couple of other opportunities when he was in the Met Office. The war, of course, was not at all a teaching opportunity. I think it might have just been, and he got to assemble his crew in the synoptic dynamic research in the reorganization of the Met Office after the war. That's where he hired Sawyer, he hired Bushby, he hired Mavis Hines, all these great thinkers. So I think he always had an eye for finding excellent talent and nurturing it. And then being a professor at a university is really not very different from that in a lot of ways. And I think he must have seen that. I think his experience also with his science master and his headmaster at Whitcliffe Mount were influential on him. I think he saw, even as a math undergraduate, he saw that teaching is a profession that it gains respect. He didn't want to do it in his 20s, but he knew that it was a respectful life. So I think coming back to it, he may have just thought, this might be the best way for me to continue to advance my ideas about how our science will move forward. At the time, he was thinking about how operational meteorologists and academic meteorologists were on different universes, completely different frequencies, and he wanted to try to bridge that gap. And I figured, I think he must have, at least at some point in his determination to take the job at Reading, thought, well, I should stop complaining and get involved. And I think that might have been one of his motivating factors. So another really great question. It would be wonderful if he had a diary left. He has a few interviews, but nobody asked him that interesting question. I wish they had.
And Julian, thanks you for the additional figures that were not in your biography. We have another one from Martin Young. I think it's very interesting. So the interesting legacy of Sutcliffe is that 1,500 millibar thickness lines are still shown and issued by Met Office medium range forecast charts with isobars and fronts. Probably a legacy of when Sutcliffe theory was applied in preparing such charts in pre-computer days.
Yeah. Yeah, it's a long-standing legacy, isn't it? It's really remarkable, hard to explain in some ways, because there's so many other ways to look at circulation systems in the mid-latitudes now. One could use PV and surface theta, for instance, and really find almost exactly similar insights would gradually be accrued in the forecast office. But that 1,500 millibar thickness is just going to be really hard to let go of that, because it does have so many nice connections to other branches of basic theory. That's an excellent question all by itself. How long will it be? You could probably take odds on that question. I don't know how long it might be.
It better stay. It better stay.
Yeah.
That's a great product. We have the next one from Jim Fleming. Says, bravo. Does the family have books that were in Sutcliffe's library? I'm thinking of Willem Bjerknes' mathematical works.
No, this is one of the really, thank you, Jim, for that question and for your comment. Sutcliffe, in one of his interviews with the Met Office, who was it? Burton's interviews of Sutcliffe. Sutcliffe makes a big point to Burton, almost with pride, that he got rid of almost everything that he ever acquired as a scientist. Not all of his personal papers, but many of his personal papers and almost all of his books. And then he and Evelyn had the misfortune when they moved to the South Coast, they had to store all of their prior possessions at Portsmouth. And then Portsmouth was firebombed. And my suspicion is that they lost a lot of things in that firebombing. And it might have made Sutcliffe pretty cynical about whether or not he ought to save anything after he'd lost all that. Undoubtedly, there were letters between him and Evelyn that they saved, because I don't think he was, unromantic in that regard. But I think he might have just been soured on the whole notion of saving things. But there's no books, and there's very few photographs. There's a lot of professional contract type papers, but not anything that says, here's why I was thinking about this and when I was thinking about it, which you'd really like to have from him. No notes on the side of books. So that's unfortunate. So it's a good question, but no, as far as I know, I should say that.
I don't see other questions in the chat box. I'm inviting everyone to ask direct questions if anyone wants to. John? While we're waiting, I had one for you, John, as well.
Okay.
And it occurred to me when you were showing the picture of Sutcliffe and Rosby talking, and when you're talking about baroclinic and barotropic. That's fascinating, and that's a story that should be told really in more detail. But I'm wondering, you recognize that Sutcliffe was not given the proper recognition given the contribution. Now, why do you think that's the case?
That's a good question. My sense from his daughters, and also from his distaste for Mason's, how do we say it? Not showboating, but Mason was very good at getting publicity for the Met Office when he was director, and for himself before he was director at Imperial College. So, and then later at Imperial College. I think that turned Sutcliffe off. I think that was one of the skills that he never really wanted to hone. Maybe he had no desire to be that kind of a person, that kind of a, what do we call it now? Branding. I don't think there was any branding instinct in Reggie Sutcliffe. And that may have been one of the reasons why his contributions were not seen for the importance that they maybe brought to the science. But that's just a guess. So I think there is a combination of, you do really find important work, and you propagate it a little bit and you publicize it a little bit. It's easier to do in our age than it might have been in the 40s, 50s, and 60s, but people still were able to do it in the 40s, 50s, and 60s. And as a consequence, certain reputations get a little bit more notoriety than others that you might consider to have equivalent status in terms of contributions. That's the best I can do. I mean, I see it a little bit in our own, in my own circle of colleagues. There are certain people who are fine people and doing great science, but not any better than some of the other people I know. And yet they seem to have some knack about attracting publicity for themselves, even if they don't try to do it. It's just one of those weird things, I think, that happens in populations. But I don't know more than that.
Do you think Rosby had more branding skills?
I think Rosby was more of an entrepreneur. So I would say that I wouldn't say branding so much in Rosby's case. My sense of Rosby is that everything he touched, he organized to a higher level than it could have been organized by almost anybody else. And he made a lot of different stops around the world. He was in the US for a while. He was in Sweden, of course, for a long time. And he touched lots of different organizations, and there was a Rosby magic to that, which was to his credit. He was an exceptionally entrepreneurial thinker. And he recruited people of the highest caliber and got them to believe in what he was doing to a degree that maybe Sutcliffe was not quite as good at. He was good at recruiting, but I don't think he was as good at proselytizing.
Thank you, John. Thank you for that great picture of Sutcliffe and Rosby. Any other questions?